record and then share my screen. Let me know if you cannot hear the video.
Hey Packet Heads, welcome back, and now we are on lesson 3 of the Wireshark Masterclass. Now in this lesson, what we're going to do is take a look at the command line and learn how to capture using command line tools. Now there's some environments where it's a lot easier to use the command line to capture rather than the user interface within Wireshark. So get out that command line and let's capture some packets. Okay, so in this lesson, we're going to talk about the command line tools. Now, when you install Wireshark, you also install several tools, and we're going to progressively talk about those as we go forward in our course. So things like merge cap, edit cap, T-shark. But in this case, we're going to talk about how to capture using either dump cap or TCP dump. Now, maybe in the past, we've captured off of a firewall or a load balancer using one of these types of tools. And now we're going to learn how to do it from our local machine. All right, so I'm going to show you guys real quick how to access the command line tools within a command prompt or within your terminal, depending on your operating system. I'm just going to show you how to do it on Windows first, and then we're going to flip over to Mac and show you it there. So on Windows, if we just come into our search, we're just going to type in, we can just select command prompt or type in CMD and we'll be able to find it. Now, just right off the bat, if you start typing in something like T-shark or dump cap, now, unless you actually have the Wireshark directory as a part of your path, this tool won't work right off the bat. You're going to have to add the Wireshark directory as a part of the path. And there's a handful of ways to do that, but just to really understand this principle, I'm just going to back up a few directories, and I'm going to go into my program files. And then I'm going to go into Wireshark, if I can type it. Okay, so within Wireshark, there I actually have my command line tools. So there I'm going to see T-shark, and I'm going to come in here. I can see a handful of other ones that I can actually use, merge cap, and so on. So this is where they actually are located. So from here, I would be able to do dump cap, TCP dump, and all of the command line tools that get installed with Wireshark are going to be located here. So it's always a good idea to add this to your path environment variable. In fact, if I just print mine out, path, you can actually see here on mine, if I come down here, it's right here. So C program files Wireshark. What that does is it means that I can run those tools from anywhere within my command prompt, no matter where I'm at. All right, so to do that, a simple way, there's a handful of ways, you can Google them, find your favorite way. But a simple way to do that, if I just jump down to my little search tool, if I go to the control panel, and I'm going to come into my system settings, going to go to advanced system settings, I'm going to come down to environment variables. Here I'm going to see path. All right, so then I can edit, and this is where I can add. So I'm going to say new, and let's go ahead and browse. This is where I can say new, and this is where I can browse, and this is where I can come in and find my Wireshark directory. That will add that path to my environment variable, so then I should be able to use those tools from anywhere that I am within my command prompt. Okay, so that's how I can access the command line tools within the Windows 10 environment. But how about on a Mac? Now, on a Mac, the actual location that these tools are typically installed, you can see it here. This location is applications wireshark.app contents Mac OS. So what I want to do is I also want to add that to my path. So what I'm going to do is I'm actually going to put this down in the description below. You can see this. To come into my terminal, I can just add this as a temporary addition to my path. What that will do is that will allow me to run the command line tools from anywhere within this terminal. But as soon as I turn the terminal off, then I'm going to have to do this every single time. So to add this as a permanent path environment variable, I'm going to go ahead and link to another article that will show you how to do that on a permanent basis if you're on a Mac system. So now that we know how to actually access the command line tools, let's go ahead and get busy using them. So I'm going to go ahead and open up here. I'm on a Mac system. So I'm going to open up my terminal. So first, what I'm going to do is I'm just going to say dump cap -H. Now, the nice thing about this is we can see some of the options that we have available, things that we may have also seen within the Wireshark analyzer. So here I have -I, that's one that I want to make sure that I use to tell the system what interface I want to capture from. Now here also we see snap length, and that's how we can tell the system how much of the frame do we want to capture. Also we have buffer size, and we also have list interfaces and several different things. So basically, let's just keep this very simple. So I'm just going to start over, and what I'm going to do is just go to dump cap. And to get a list of my interfaces, I'm just going to do -D. And what that does is it lists out all the interfaces on my system. So rather than guess at the index number that's used for those interfaces, now I can actually see which one is assigned. So here I can see EN0, that's my Wi-Fi interface. Down below, if I had a Thunderbolt interface connected to an actual physical cable, down there, I might use interface number 13, 14, 15. So this will show you all of the interfaces, and you can select which one you want to capture from. So for me, just to test this, what I'm going to do is dump cap -I, that's interface, and I'm just going to say 1. That's my Wi-Fi interface. So I just hit enter, and it shows me, okay, Chris, you nailed it. Capturing on Wi-Fi, EN0, and this is the location, just the temp folder where I'm saving this data. All right, so I'm just going to say Control-C just to stop that capture. Now I know that I've got the right interface that I want to use. The next thing that I want to do is I want to tell DumpCap where to save the data. That temp folder isn't something that I'm going to go digging around through in my system. So what I want to do is I'm just going to hit up arrow. Okay, so DumpCap -I, the first interface. Now I'm going to do -W, so to write. Now, where do I want to write? I'm just going to say to users, Chris. Now I've got a data folder, and I'm just going to name this sample.pcap.ng. All right. So now I've told DumpCap, save off this interface and save in this location. So let's go ahead and see what happens. I'm just going to hit that. And if I bring up my Finder here, this is where I can see that I'm capturing and I'm saving to that sample trace file. Now this will keep running, and that sample trace file will grow on until I stop this capture. Now, let's just say I want to take advantage of a ring buffer, but I want to do it from the command line. We learned about ring buffers in the last lesson. So let's go ahead and see how we can, instead of capturing one large packet capture off the command line, how can we break it up into smaller pieces? Okay, so I'm going to go ahead and stop this. Now this gets a little bit long as far as an actual single command, so it can be tough to remember all the switches. That's why don't be afraid to go ahead and go back to dumpcap-H, and this is where we can start to see some of the options that we have to use within the system. So after I bring up my help again, now I want to take a look at the small b switch. So I've got -B ring buffer options. So this is where I can tell the system, do I want how many files, what's the file size of each one of these? And remember that those file sizes are in kilobytes. All right, and the files can be a number of files. All right, so let's go ahead and create a dumpcap ring buffer. All right, so I'm just going to up arrow until I bring my old command back. So -I, that's my Wi-Fi interface. And here I'm writing to this location on my system. But this time what I want to do is I want to do -B. And what I'm going to do is first file size. Okay, and then I'm going to do colon. And what I want to say here is how large do I want those trace files to be in kilobytes. So if I just put 100, that means it's going to save 100 kilobyte PCAPs. So that's pretty small, right? So I might want to up that a little bit. If I add one more 0, that's a meg. Add one more 0, that's 10 meg. Add one more 0, that's 100 meg. All right, so this is going to be 100 megabyte PCAP. Now, in our lesson last week, we talked about using 500 meg PCAPs. Oops, I put 6. Let me back that out. There's 5. So right there, that's how I tell it. I want 500 megabyte PCAPs. And how many of them do I want? I'm going to use another -B. And this time I'm going to say files. So how many do I want in my ring buffer? Let's just say for starters, 10. So what this does is it's going to save 10 total 500 megabyte files. And on the 11th one, it's going to go back and overwrite the first one and then overwrite the second one. So I'll only ever have 10 in total. So just looking at that, that looks good. So I'm just going to say, okay. And you'll notice over here on the left in my data folder, this is where I have my first PCAP that's starting, and then it's going to be collecting data. Once it hits 500, then I'll see sample number 2 and a time and date stamp. Then I'll see sample number 3, time and date stamp, sample 4, and so on. Once I hit 10, then I'll see 11 and it'll overwrite number 1. So keep in mind, if you're in a high throughput, high bandwidth environment, you might want to use larger PCAPs, and you might want to have more in your ring buffer just so you can make sure to keep up with the ingress data. So this is how you capture on the command line. Now, why would we want to use the command line instead of the user interface? Well, sometimes we're on the command line a bit more, and we like to use this type of tool to use our packet captures to bring in that data. Also, Wireshark in the user interface, it's a heavier way to capture, right? So it has a lot more going on. We might not be able to keep up with larger data rates coming into our system with the user interface. So just to make sure, this is the most raw way that you can collect packets into your analyzer. So I hope this was a useful tip for you. Thanks for stopping by at the Wireshark Masterclass Lesson 3, and I'll see you on another video.
Okay, so that's it for that one. Yeah, I'm not particularly fond of Macs either. I've had to fix all sorts of things, and once you've had to fix Macs, sometimes you get a hatred for them. So there. Any questions on that? I mean, we're not really going through that right now, but I just thought you guys would be interested because there were some people that asked about it.
My question, what's a packet?
We were here yesterday. I think you should know. Okay, so tonight we are going to do basic router configurations for Cisco. And Cisco can be particular about a lot of things. So this is how Cisco, remember how I said Cisco environments can do slightly different things than others. So this is how Cisco's environment does theirs. Okay, everybody see everything okay? All right, so basic configurations. And I have a videos of a guy that walks through it just like from scratch. So you guys can watch that after this. So they are often, there's like, instead of doing a GUI, it's command line. So you will get very comfortable doing a lot of command line things as you're working on this. So so for here, the top one, that's how you do the configuration for the host name. This is just basically a info dump on how to configure these basic things. And there's the switches and stuff for that. Secure privilege, exec mode, secure user exec mode, secure remote telnet SSH access, encrypt all plain text passwords. Please, 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 please don't ever use plain text passwords. Provide legal notification and save the configuration. I will say that it is a good idea to make notes about what you're doing in case you have someone like, for example, we jokingly called it the in case you get hit by a bus clause. And that was just the sarcastic way of saying, make sure you write notes in case something happens to you and you can't be there, like you're at a conference or something happens and you can't make it in. Someone else has to be able to access and look at how you do things. If you can't do that and you need that in an emergency, it can be very critical and difficult to do that. Okay. Here's some other ones for basic router on R1, and then configuration is saved to NVRAM. And you can see on the bottom here, copy, running config, startup config. And configuring a router interface includes issuing the following commands. And there you have the interface description, IP address, IPv6 address, and then the no shutdown command. It's a good practice to use your description command to add information about the network connected to the interface, and the no shutdown command activates the interface. It's one of those weird things that's just happened to be how they use that. Now, the reason that you want to use your description command, that I have seen people that don't use that, but a lot of times it's like putting, if you've ever done any programming, it's kind of like putting the explanatory text in for the people that come afterwards and have to fix things possibly. Or if you're like, oh, what was I doing when I was working on this? That's kind of like adding notes to it about your environment. Commands to configure interface, G00 on R1. And you can see there's just kind of an explanation of where it's placed. The one circled in orange is what they're talking about. And if you look down on the bottom, you can see what it would look like if you were doing the full configurations. To verify interface configuration, use the show IP interface brief and show IPv6 interface brief commands. And the reason that you want to do that, you see that section where it says okay, question mark, and status. Those are whether or not things are coming back correctly. If it says status down and you just did something that you should be bringing it up, you know that it was put in incorrectly. And this is just a table that summarizes commands that you can use to verify interface configuration. The first one's that show IP interface brief and show IPv6 interface brief. And then there's the show for IP route, show interfaces. This one displays statistics for all of your interfaces on the device. And then show IP interfaces displays the IPv4 statistics for all interfaces on a router, and then you have one that's show IPv6 interfaces. Okay, view status of all interfaces with the show IP interface brief and show interface IPv6 interface brief, and you can see those both there, and you can see that there's obviously going to be a difference between the IPv4 and IPv6. IPv4 is on top, IPv6 is on bottom. Display the contents of the IP routing tables with the show IP route and show IPv6 route commands. So the top one again is IPv4, bottom one IPv6, and that's what those commands will show you. Okay, so this display statistics for all interfaces with the show interfaces command. And as you can see, it just kind of dumps all your information right there. You've got your hardware, your address, description, internet address, MTU, encapsulation. It just dumps everything, so you can see it right there. Display IPv4 statistics, and that does the same thing. And this one's IPv6 interfaces. All right, next we're on to configure default gateway. The default gateway is used when a host sends a packet to a device on another network. Default gateway address is generally the router interface address attached to the local network of the host. To reach PC3, PC1 addresses a packet with IPv4 address of PC3, but forwards the packet to the default gateway, the G0/0/0 interface R1. And you can see in that it's got the loop from PC1, hits the router, PC3. Now, they keep throwing that in there that it has to be on the same network in order to reach something on the same network. So just so you guys know, that one is a question you're going to probably see either in a quiz or a test. So make sure that you are remembering that. A switch must have a default gateway address configured to remotely manage the switch from another network. To configure an IPv4 default gateway on a switch, use IP default gateway, IP address, global configuration command. And you can see there's a little text box up here that shows that. And then on the bottom, you can see it applied. And these are just different things that you can do on Packet Tracer. We will go through some of those next week since I'm feeling better, and I can actually use my big rig computer and we can walk through some of those. Yes. Looks like it was super fast on those. Okay, so the video on the next part here is about 18 minutes long. Before I start that, are there any questions about routers or any of the configurations and things like that? I know this one is one of those that you just kind of have to mess with in order to get it, and you have to look at it a lot. So are there any questions on this one before I start the video? I enjoyed the video because it goes through a bunch of I mean, you're visually seeing someone do the things that we were just talking about. So I think you guys will maybe not enjoy that, but I think you'll be able to get more clarification on that. We good? Okay. Butter or no butter on my popcorn? I am a no butter sea salt person actually on my popcorn.
Man, I'm just learning things about everyone. Zach likes mac. You don't like butter on popcorn?
I do not. And mostly it's not that I do not, it's that I have high cholesterol and my body says, you know what? I don't like this.
That's different.
So I do like popcorn though. So let's see. Pop that out here. Let me know if this guy, or this isn't the guy with the difficult accent. So there was one that had an accent that was a little more difficult to understand, but I think this one we should be okay with.
Cisco router can be a tough call if you've never done it before. In this video, I'm going to show you how to configure a Cisco router from scratch. Hi, this is David Godibadze from IT Solutions Network. I've been in the IT world for over 20 years and now I have my own YouTube channel. Let's get started. Okay, let's start. So I have a computer here with static IP addresses on it, and I have a Cisco router with the empty configuration. There's no startup configuration at all. And there's an ISP. We have subnet and the IP addresses from the ISP, and we have internal network information. This is Cisco device.
Yeah, I was wondering about that. Let me know if the captions cause a problem with you guys seeing what's underneath them. I can always rewind the video and watch parts of it without captions.
And it has no configuration at all. This is the first boot, and as you can see, we get all these messages during the first boot. So we need to go into enable mode, and in the enable mode, we can try and run the command show IP interface brief, which will give us the information about the interfaces we have. They all are down, means disabled, and we don't have the IP address assigned to it. As you can see in the topology, we're gonna use Gigabit Ethernet 2 for the inside interface, and we're gonna use Gigabit Ethernet 1 as an outside interface. Let's get started and configure them. Show IP interface brief will show us information about the interfaces we have. So we have 4 interfaces. All of them are shut down, and we don't have the IP addresses on them. We need to configure these interfaces in order to, have the configured router. First, we're going to configure the Gigabit Ethernet 1. That's in our outside interface. IP address 12.34.56.2, As you can see on the topology in the background, that's our IP address. We need to enable this interface, and then we need to configure the Gigabit Ethernet 2 with the IP address 192.168.2.1/24 again. No shutdown. So let's see what we have now. This is what we have. We have inside IP. This is what we have. We have inside IP, we have outside IP, and let's try in the ping ISP IP address. That would be .1. Okay, we can ping ISP, and we enable the interfaces. Let's see if the computer can ping a Cisco router. Okay, we already have the IP address on the computer, and let's go ahead and try to ping Cisco router by typing ping 192.168.2.1. Okay, we can ping Cisco device. Perfect. Let's move on and try to add the default gateway. The reason why we need to add the default gateway because Cisco doesn't know how to go to the outside world. So if we ping Google DNS, Cisco won't be able to ping that because it doesn't have a clue where to go. And to make sure, we can check show IP route, and as you can see, there is no default route in the routing table. So what we are going to do to fix that is we're going to add the routing table. We're going to add the default gateway into a routing table. And our default gateway will be 12.34.56.1. And if we check routing table again, we'll see that now we have this default gateway. And if we ping Google DNS, we should be able to ping it. Okay, perfect. We can ping Google DNS, but that's not enough to allow inside computers to surf the internet. So if you ping Google DNS from the computer, you won't be able to ping it. The reason for that is that we don't get the answers from the ISP because ISP doesn't know about these internal subnets at all. So what we need to do is translate the source subnet, any IP from the subnet, into public IP, which is 12.34.56.2. And to do that, we need to create an access list to match the traffic. Then we need to put the global configuration for the net, and we need to do NAT configuration on the interfaces. So let's create the access list. Permit, to match the traffic, we need to use permit IP, and our source subnet will be our internal subnet and any destination. Then we need to put the actual NAT configuration. We're going to use the access list we just created, and we want to translate our source subnet into Gigabit Ethernet 1 IP address. And we need to enable IP NAT inside and IP NAT outside on the interfaces.
And that's NAT, N-A-T, not the
Perfect. So
The
now
subtitles
we should be
weren't
able to
getting
ping Google DNS from the Windows computer, and we are able to ping it. Okay, now let's make it easier. We want to have the DHCP server running on the network because we don't like to use static IPs just like we have on this Windows computer. And for that, we need to create DHCP configuration on the Cisco device. Let's first exclude several IPs from the pool because we could use these IPs to manage the access points, switches, or all sorts of stuff. IP DHCP. Excluded address 192.168.2.1, and let's make it 10. Okay, so all the IPs from this range will be excluded from being assigned on the computers. Now let's create the actual DHCP pool. Name it LAN subnet. Put the network. Put the default gateway because we obviously need to have the default gateway on the computer. Once the computer gets the IP address from the DHCP server, and we also need to have the DNS server. So let's do the DNS server as well. Perfect. Let's go ahead and try to change it to the DHCP client instead of static IP, instead of manual IP, and see what's going to happen. Okay, so this is our first IP, .11, remember, because we excluded all the first 10 IPs, all the IPs from this range, first 10 IPs, and that's why we have .11. We have the same subnet as the configuration, and we have the gateway as per our configuration, and of course we have the DNS because we included the DNS in the DHCP configuration. Perfect, it's done. Now let's configure the remote access because we don't want to use the console cable and physically connect to the router every time we want to run the command or check the status or like troubleshoot or change configuration. Let's go ahead and enable AAA new model, which is authentication, authorization, and accounting, and create a username, Cisco, and the password, Cisco123. Now, you might have seen that some people use password instead of secret, but remember, password is not good. It's bad. It's unencrypted. It can be decrypted. It's no good. Just don't use it. So every time you have to create a username inside the Cisco device, use secret instead of password, okay? And we need to create the enable password because we didn't add the privilege mode on the user here. You can actually do that from here. We cannot. That's weird. Okay. So now let's create the enable password. And again, we use secret, not the password. We have an option here to use the password, but use secret. It's more secure. And our password will be SA. Okay, perfect. Now, in order to allow, let's first connect through the telnet and see how it works. Cisco123, enable password, SA. Perfect, it's there. But remember, telnet is not good because it's a plain text. If someone captures the traffic, they can see the password. That's why we want to use SSH. And in order to use SSH, we need to generate SSH keys. And to generate SSH keys, we need to assign host name and we need to give domain name. So let's go ahead and do that. Host name would be R1 and IP domain name would be David Lab Local. Okay, that will work. Crypto key generate RSA. This is how we generate SSH keys, and we give the maximum bit key size because we want to be more secure. We like security, and because SSH version 1.99 is vulnerable, we want to change it to version 2. Okay, perfect. Now, if you remember, we didn't disable the telnet. So if we try to connect, we are still able to connect to it, which is not cool. We need to disable telnet. And to do that, we go into line with the line 0 up to what we have 98, and we do transport input SSH, and we don't include telnet, only SSH. This will disable telnet, and nobody can use telnet anymore, which is good because we don't want someone to use the telnet. We only want to use SSH, right? Now we want to make it more secure. So let's add the access on the outside interface and on virtual interface for the SSH. IP access list standard. So we want to allow connections only from this computer with IPs .11, I believe. Yes, let's go ahead and try to add this IP only. Read UI filter. Permit 192.168.2.11 and assign this access list to the virtual port. This is how you do that. Access class, HUI filters, filter, and for inbound connections, incoming connections. Cool. Now if we run this access list, there's no match because we haven't tried.
Okay, I'm gonna keep going here, but are there any questions so far? That anyone has?
Right, connect to it.
Do you want the captions off? I that's why I turned them off, because they were kind of in the way of the, yeah, they were in the way for me too. Give me 1 second
But if
here.
we try using party game, for example, we will be able to see match in this access list. You see? So if you change the IP on the computer, we won't be able to connect to the Cisco device anymore using the different IP, because we didn't put the whole subnet here. We put only one IP. Now let's create access list for the outside interface. Outside filter, and let's add some of the lines there. So first, let's allow the ICMP echo replies, because if we ping something from the inside world, like this, for example, right, we want to receive replies. And to do that, we need to allow ICMP echo replies. We're gonna allow the ICMP echo replies only. So what this line says that the permit ICMP protocol coming from any host, coming from any source to the host of our public IP, and if it's echo reply. Okay, so that means if someone pings our IP from the outside, they will not be able to get the response. But if we ping from the inside, we will get the response. Permit UDP any equal domain and host 12.34.56.2. Now what this does is we allow DNS responses to come in inside the router from the outside world, because when we try to ping Google, for example, or Apple, the computer will try to resolve the IP address, and for that, the computer will use port 53 on Google DNS, and that's what we are saying, that the permit UDP protocol coming from any source, that the source port is domain 50, that's a UDP port 53, and this is not the UDP port, this is just port 53, and this is how we say that it's a UDP. So it's a UDP port 53, and if the response comes to the IP with the destination in IP header 12.34.56.2, allow that. And also, when we try to surf the internet, for example, google.com or apple.com, we want to allow these responses also to come in without allowing anything extra. So for that, we do permit TCP any source to the destination 12.34.56.2, and here's the keyword here. Oh, hold on. And here's the keyword here: established. Match established connections. That means if the connection is reply for the connection that was initiated from the inside, it will allow that. But the new connections, for example, someone's trying to SSH or someone's trying to do any kind of TCP connection, router will not allow that. It will drop the connection because it's not the reply for the connection initiated from the inside. Now let's assign this access list to the outside interface. For that, we go into interface configuration mode and type IP access group, then access list name, outside filter, and direction of the packets. In our case, that's inbound. So if we try to see the interface configuration, this is what we have. We have IP address. We say that it's a not outside interface. This is the access list. By the way, we can see match here. You see, there's no match yet, right? Okay, we have two lines because he accidentally pressed the enter here. Let's remove that. Okay, perfect. Now, let's go ahead and try to resolve the IP address and ping. So because of this command we ran on the Windows machine, we will be able to see match here and match here. You see, we have 4 packets because Windows sends 4 ping packets by default, and we have 1 match because we tried to resolve the IP address. And if we also try to telnet on port 80, we should get match here on the 3rd line. And of course we have it. Now let's save the configuration because it's already done. We already configured everything we wanted in this session, and it's now time to save the configuration. Copy running configuration, startup configuration. So what we say here is take configuration from the memory and save it into startup config file. So next time when we boot the router, it will load the configuration from the startup config file. And this is it. Basic configuration of the Cisco router is done. We have assigned the IP address. We enable the network address translation. We add the static route. We configure the remote access, and we add some little bit security to protect our remote access and to protect the outside traffic.
Okay. Did that help some of those concepts come through a little bit better, watching him go through and set everything up from the beginning? Yeah, okay. And I'll dump the link in here, but I'll also dump it on both of those links that I had on Discord for you.
My question was it just him having like a twitch or something when he was typing that was why the commands were broken up over like 30 line, well, not 30, that's an exaggeration, but like 5 lines when he was typing in commands?
Which one are you talking? Let me hold on one second.
When I was watching him enter commands, it would be like I can't think of any off the top of my head, but it would be he'd have like part of the command written out, and then right below it part of the command, or another part of the command only going further and then further and then further.
That might have been the way that his command prompt word wrapped it. Sometimes when you're doing command lines and you have it like your screen minimized, it will automatically just bump it down to the next line, depending on how you have things set up. And I'd say looking at he's got some odd margins set on his. So that's probably what caused it to bump down like that.
I was just wondering if like Cisco was kicking the command and it was kicking the command back or something, and he was or if he was just having like a twitch or something.
Usually if it kicks back a command, you'll get an error code. It'll tell you, I don't know what that is, or that's not a valid command or something like that. Sorry, big black fluffy cat trying to help. So usually on those, it's either he's just word wrapping, or it's a quirk with the visual presentation on it. Does that make sense?
Yeah, it was just bugging me. I was wondering if it was something I could expect to see when like I was trying to do it.
I don't believe so. The only time I've ever seen it is with word wrap, and when you get incorrect ones, I've always, at least with Cisco, when I've ever seen it, I've always gotten error messages. So I think that's what was going on, was just it was bumping it down.
All right, thanks for the info.
Yeah, no problem. Anybody else have any questions? No. Okay. So that's pretty much it for tonight. Tomorrow is our ethics lesson / discussion. So just remember that, and we will get together and talk, and remember that there are terms from the ethics discussions that are in the tests. So keep that in mind. And the PowerPoint for that will be from all of these will be out, including the ethics one, on the Blackboard PowerPoint section. So stick around if you have any questions. Otherwise, head out there and hit the books and let me know if you have any problems. And have a good week, not a good weekend. Sorry, I'm a day ahead. Have a good night and I'll see you tomorrow.